Well, hello everybody. Welcome back to Camp Colder's workshop. Some of you might have guessed I'm a prosthetics user, builder and repairer. I do that as my hobby. I get the prosthetics from various markets, some from the USA, some from Russia and some from Europe. Just depends what's around when I go looking. So I bought quite a few knees, prosthetic knees, and quite a few feet have come with those knees. So I've actually got 8 different types of feet, and I thought what I'd do is just review them, having used each one, but also do a bench review on them and just quickly go into how they're constructed. I feel my background to do this is as a part-trained engineer, and most of my life I've rebuilt motorbikes and cars. In the case of motorbikes, from just an empty engine literally and a scrap frame, I've managed to rebuild bikes. So I feel reasonably qualified to undertake my hobby, which is constructing my own prosthetic legs. So I'm not offering advice on prosthetics. What I'm doing is sharing my experience as a user of prosthetic limbs, and I thought today I'd do feet. These prosthetics themselves are all non-electrical. They're all basically either carbon or rely on rubber grommets and suspension units to operate, so no electrics. But if somebody wants to send me an electric one to test, I'd be quite grateful to do so. So let's have a look at the methodology I've used. As you can see here, I've put around 8 to 10 kilos of weight on here to simulate the weight of a knee and a leg. Having this weight on here also allows me to use the foot and extend and retract the foot as it should be in actual use. So that's the reason for the weight here, and that's part of making the test relevant to actual use as far as I can. So all the feet will be subjected to a similar force and a similar weight as part of my bench test. So I'm also going to test the foot in 3 main areas of walking: on the contact phase, which is here with the heel, so how the heel strikes, how the foot performs on a mid-stance phase, which is here, and how the foot performs on a propulsive phase, which is here. I'm also going to check the behaviour and operation of the foot on an uneven surface, and see how the foot deals with these slopes, what the supination and pronation of the foot is in terms of its design. So and also the that is the side-to-side movement, and the pitch and yaw, which is the front to back movement, and see how the foot is designed to cope with that. I'll also test the feet on a 17-degree slope as well, to see how well the foot does with going uphill, as well as the 13-degree that I'll be using for the supination and first test of the foot dealing with a rise in level and going down the slope as well at 17 and 23 degrees as well. So to make the test as valid as I can, the feet that don't have a prosthetic foot on them, as you can see, a lot of feet do actually come with prosthetic feet as standard, but some don't. so what I've done there is I've cut out a piece of rubber to simulate having a prosthetic foot wrapped around the foot unit itself. So I've tried to make this as equal as I can, and also I will be testing the foot's reaction to one of the aids that I use, which is actually a Soulmate, and this is a liquid sole that I put in all my shoes, including the prosthetic shoes and normal shoes. And the idea of this is that it cushions the action of the foot in such a way, like a liquid suspension mechanism. So I'll also be seeing how that interacts with the feet as well, and if it does make any difference to them. But as I say, I use these all the time in all my shoes. Okay, so what I propose to do is, as I said, go through each foot in turn, see how it works, and then test it on the bench and see what kind of results I get. There's going to be no winner in this, just a survey of how the different feet interact with the tests on the bench and how they feel with regards to each other from the bench test.